Okay, let's get going again. So, today, so yeah, my computer, well, actually, my computer screen cracked, and so I had to get a new laptop and get that all set up. So I haven't done some of the episodes in a while, but, I now have Git and everything on here, so now I'm going to kind of work through, some of the code for the Riverflow notebooks and kind of fixing it up. And mainly tonight we're actually going to look at kind of getting the tables ready for BigQuery. So basically the idea is as the scraper runs, it's going to save the results of the scrape to BigQuery using this kind of BigQuery connector class. And there's actually going to be kind of two tables we put on BigQuery, or well, of course, a lot more than two tables, but there's going to be kind of two varieties of tables we generally put on. One is going to be just a big table with all the metadata, and then the second is going to be the actual kind of scrape data, and there'll be tons of tables with that, but some of them will have slightly different schemas, mainly depending on if they're Snowtel tables or whatnot. So we're of course not going to get to all of that tonight, but we're just going to start kind of adding some of the requirements here to the file, and then also in particular working on creating that kind of first type of table to record the kind of the gauge metadata, so then it could be queried easier. And yeah, so that's kind of what we're going to do there. And then later on, we still have kind of the issue. I think if you saw the last video of how to get the Sentinel metadata, which was, or how to get the Sentinel index.csv file, like basically how to store it, because it is a very large file. So we might also touch on some of that tonight. I did resolve the hour discrepancy, so that's closed now. So we can kind of move on to some of these other issues. And actually, before we start this, I just realized I didn't actually have these BigQuery things as issues on the repository. So always a good idea to kind of create the issues, particularly it doesn't matter as much on, like, of course, one of these projects, but particularly when you're working with a company and other teammates, you do want to add those things so people kind of know what you're doing. And then often, like, then if it comes time to show, the director or whatever what you're doing, then you can point to, well, I closed out these issues, blah blah blah, etc. So and even on an open source project like this, if anyone else is working, then they can kind of see it, and you can track to kind of your own metrics, how many and what types of issues you're getting done in a week. So always good to kind of fill those out and have a record. So we're going to call this create BigQuery table of USGS metadata. So basically, as this says, we can also label this. Of course, this is data engineering. So we So basically, we want this to be in the infrastructure repository probably as well. for this table at least. The other tables will actually be in, or the code to create the other tables will be in this, since they'll actually be ran in Python. So we're gonna do, so yeah, we're gonna probably create the table right here in the tables thing. We already have, I think, one table. Oh, we already started this, so we actually did already start this. Infra so we're going to do that, and then we'll kind of continue from there. So okay, infra FlowDB repository. We want to create a table on GCP to store the metadata for UGS, USGS. So yeah, we'll just put a link there too, since this is marked down, and then so in the existing repo, and then what we want to do is so basically we're going to do this in 2 stages. One is like just creating the table, and then we're going to probably run some code through the bucket to then add each individual JSON file to the table. And what this does is, I mean, it's not strictly necessary. If you looked at FlowDB, the first version, we actually just had all the metadata still in JSON files. But this is really for kind of thinking about our end user, and particularly like if people are coming from, say, more of a SQL background and are analysts and stuff. It's they're gonna want to probably just query in BigQuery work rather than work with the JSON file. And secondly, too, once the other tables, for the daily scraping data, I definitely think it does make sense to have it in BigQuery, because just finding and opening like CSV files just stored in the buckets on a daily basis would probably be quite difficult. So it's easier to append. It will be easier to append that to an existing table. So yeah, we're gonna work on that now, and yeah, I don't know if we have to add this other issue now, but that's kind of the main thing. Actually, yeah, it was kind of interesting, kind of, I guess, a digression from this, but I did actually start some training on some of these files the other night, so some of the files I do think having more data did help. So I was able to create kind of just an exploratory thing of the Boulder Creek data and train DSAnet on it. So that was kind of interesting to see how that trained. And yeah, there were some kind of interesting results for some of the forecasting on it. I think, what was this? That there were a couple that like trained models that didn't seem to do awful on certain tasks, like predicting the dew point, or some of them like predicted the beginning of the forecasted period. Okay. So yeah, I do think actually having more data helps. So that's why the scraping was kind of a big deal, because like if the scraping works in the right way, we should be able to get at least 13 to 14 years of data for each river. And we even before going into like integrating the satellite imagery, we could potentially test some things like seeing if transfer learning and other stuff actually works on these I guess transformer models for time series. Because like yeah, that hasn't really, well, actually it has been studied, and generally transfer learning hasn't worked as well, but I think I have some training schemas, and when the data is similar, it probably should work a bit better. But in any case, that's kind of more of the research, like ML side of the puzzle. But yeah, so anyways, we'll kind of keep going from there, and we'll create the querying thing. Oh, I don't think I've even cloned the infra thing here. Clone existing clone what was that? I was gonna clone DB infra FlowDB. I don't think I've installed actually Terraform here yet, so I'm gonna do that. I had another video that I was thinking of making too. I recorded setting up this development environment, so I may put out a video on that. I mean, there have been a lot of videos on setting up kind of dev environments, but yeah, I think not too many on data science ones, so I might publish that later. So Terraform. Okay, so Terraform is on here. So yeah, we can then go clone this repo. Or I just cloned it. And then throw in a thing here. So let's open this up too. So we'll open this up. Yes, I trust offers. So buckets, yeah, we don't have to touch that. We're not creating a bucket. So this is the schema for the meta. It's in the JSON format. So it is there. I don't think we've actually run the apply here yet. So I am going to check this over. And here's our schema. So we have things like ID, state, latitude, longitude, elevation, closest ASOS ID, ASOS, closest scan site. So there are a couple fields I think we need to add, and for doing that, we'll actually, I think, throw up a JSON. I don't get why when I do this, I really wish that VS Code would by default keep the other project open. Like, I don't want it to, when I open something, I don't really want it to close the other project. I want them to be open in different windows, but so I do find that annoying about it. But West meta, so here is like the typical meta file. So yeah, I don't know if we're gonna incorporate all the soil shit in it. I just think the name, so we have ID, so the big ones are these. I don't think, as I said, we're gonna do like the soil shit in it. Location, soil data. So so these are kind of what it looks like. So let's just throw that into a, no, I don't want to mess with that. We're gonna throw that into a, I guess we could throw it in here since we're just looking at it. elevation, so we'll have to pull that when actually writing this. So yeah, it looks like we probably have ID, latitude, longitude, name, state, time zone, elevation, and then there's some shit at the bottom I think we need to. So that's the ASOS list is at the bottom. So we're not going to include this soil thing. I honestly don't think it's that useful anyways. I mean, if people want that. Oh, we should have a path to the JSON. So like if people want to view it in JSON format for that row, then we should just have a path there that you can do it. And that would include maybe the soil thing, I guess. So that sounds like probably it's a good idea. So let's see. Which ones do we have? We have ID, state, latitude, longitude, elevation. I am going to do name. That's sometimes useful. So we have the ID, but not the name. So I'm just going to put this as, it's really a description actually. So I might call it the description. Okay, so we can put that there. I forget if there was anything in the top part. Closest scan site. So scan actually hasn't been added to the meta yet. But it will be soon, probably in another query. Closest scan site. So this is the schema. So yeah, we need to get the bottom part now is the thing. Oh yeah, we're gonna do one for the path. So we're also gonna have one. So so we're gonna have the path to the JSON file on GCS. And then what we're going to have, we do want to capture some of the Snowtail info, which is at the bottom. And that might actually be it. There should be something for Sentinel though too. Okay, so yeah, Sentinel. So yeah, these things we are going to add. So yeah, I'm just gonna, obviously I'm gonna delete that before anything. And so Snowtail. Okay, so I'm gonna call this just Snowtail triplet. Because yeah, the triplet basically contains everything. Closest Snowtail triplet, we'll call that. Mode nullable type string. Okay. So, and then keep going. And then we're probably going to have another thing of the Snowtail sites maybe. So, Sentinel tile ID. Okay, so we're gonna do that. So there we go. We'll just do that. So Sentinel. So this is just gonna be the Sentinel tile ID. And then So I think that should cover it. Then we can see what the thing is later. Okay, now's the time to delete that. And that looks about right, I think. So now let's look at the table again. Come on. You always use VS Studio, or wait, no, I have it open there, so I don't even see why I'm doing that. Okay, yeah, so and then actually basically, I think I looked this over and we're not going to, schema core. I don't know what core is. But in any case, I don't think we're actually going to create these in Terraform, but in actually Python, because each river is going to have their own individual table. So yeah, so we're not going to do that. So we're going to go look then here at okay, we're going to go into this folder and we're going to do Terraform plan. Oh, Terraform init. And then go do the terraform.plan. Invalid function argument. Oh yeah, I changed my home directory here. So that's probably why, since this is a new Mac. Yeah, I'll go log in here for a second. I don't think it will require any sensitive data, but it might, so I'll just black that out. Why do that? What? So, yeah, I did install gcloud earlier. Okay, so I don't even think that showed anything, but in any case, we'll put that back on. Oh, that's my webcam. So, okay, so yeah, we did log in. And then, so let's do a Terraform plan. So yeah, basically saying, yeah, it's going to create a table and a data set, which is what we expect. So let's do this, I guess. Wait, let me rerun that. So it said free things though. Okay, so yeah. Oh yeah, it's also going to create a bucket, but I'm going to use that bucket for the actual flow data. So yes. So let's see if this creates things. Field closest snowtail triplet. Oh shit. Looks like I fucked something up in the schema. Oh shit. So this was repeated once. I don't know why the plan didn't catch that, but oh, I should change these too. Let's go back. Terraform apply. Okay, so we can rerun init. So basically it did create the thing before, so we just okay, so now it's just, I think, I think it actually should have created, because when I'm running plan now, I don't know why it's saying that bucket. I thought the bucket was created, so anyways, we can go check on GCP. So console, so we're just gonna check now. Hydro EarthNet. So yeah, there should have been, okay, so the bucket wasn't created, I don't think. Okay, I'm gonna just run this again. Let's hopefully we can just get a well then why don't I see the bucket? Okay, I don't know what that's doing then. Cause like, if the bucket was created, why isn't it showing up? Hydro EarthNet. Yeah, that's weird. Any case, yeah, I don't know why it's saying the bucket was created. I don't see the bucket created. BigQuery. So BigQuery did create the table. HydroNet. Okay, there it did. It did create the table. You can see there's nothing in the table, but did apparently create it with the fields we kind of expected. So yeah, so it did create the table. Now the actual writing of the data is definitely going to be in well, probably Python, because we're going to write the loop through and then write the JSON files one by one to the table. I don't know why it's saying that about the bucket. So in buckets / main.tf, gauge meta BigQuery, or no, buckets. Oh yeah, I mean that bucket was created. Yeah, but why is it saying it's wrong then? Yeah, well, of course I already own it. So wait, why does it think that that bucket wasn't created? Anyways. Yeah, I don't know why it thinks that. Oh, maybe because it was done on another computer. Yeah, I don't know how to get rid of that per se, though. So yeah. So basically, the table has now been created. So now we need to write the code to actually write the stuff to the table. So I think, yeah, I'm going to do that in Python. So, I might actually probably then go back to this other repo and do it in Riverflow Notebook. So, yeah, we'll do it in maybe one of these folders. So notebook ETL. Yeah, I think this could be a regular scraping. So, or wait, maybe I do want to do this on in a notebook. Yeah, maybe I will do this actually in a notebook and just add it to there. Because I mean, it's not going to be used. It's not. I don't think it will be used again. Because it's mainly going to be a script that, you know, just runs and writes to once. And actually, we're probably not going to actually run it more than a sample row or sample couple right now until we add the scan data. Because I'd rather add all the data at once than have to then update the rows, you know, individually. So okay, so but in any case, we can get the template of this thing working. So I'm going to do add meta to table. So this is definitely going to use, I think, the GCP client. Pip install. I haven't done this in a while. So GCP. So yeah, we'll do BigQuery write row to table Python. So yeah, you apparently do kind of insert it as JSON. I think this might actually even be pre-installed since it's a notebook. Let's see. I think Colab actually froze this on. Okay, yeah. So we have the client. We have the BigQuery. Now what we can do is try to get started on that function. Actually, I'm going to maybe rephrase that. Oops. I'm gonna get rid of that. From google.cloud import. I'm gonna import it as BQ. So it looks like it returns some type of errors object. Okay, so what we have to do first is Okay, so table ID. So this is going to be, of course, then looks like to go back and find the table now. Yeah, I guess it's what was also in Terraform, but I think it's just called gauge meta. So, Hydronet. So it's gonna be hydronet.gauge meta apparently. So, that should be right. But then yeah, of course we need to download the files. So I'm just gonna, I don't think I'm gonna download them all right now. What I'll do is, actually I'll probably just pick one and then we can use that from the bucket. But I'll at least get the bucket name there, and then, you know, we'll just change it to like a CPR when we're ready to do everything. It's kind of funny. CPR. I always thought about that, but yeah, copy recursive, obviously. So, yeah, let's just pick this one. Yeah. So we're just gonna do GSU TSCP GS, and we need to do off, right? Yeah, we'll probably need to authenticate. Collab authenticate. I've done this a million times. Where the heck is it? I mean, I've literally done this like a million times. Oh yeah, it's just this off, and that's off.authenticate user. Okay. We just say allow. I'm gonna actually break that up for later. What? The fuck's going on? Why can't I delete that? Okay, so now let's just write a little thing. So really, like when we write this code for real, it's gonna probably do a loop to, I think, load it. Well, like, I mean, when we do it for real, it's going to download probably something like 9 or 10K JSON files. So then we're going to probably sort that directory based on something so we can keep track of which have gone through, and then we're going to loop over, and then the loop will probably have a start and end index. Because yeah, what we're gonna have to do is probably scrape in parts, because collab will time out after a while. Though maybe it could all work in one run, I'm not sure. But yeah, you definitely don't. But for now, we won't worry about that. This is just kind of getting a feel and getting the basic outline of the code written. So So we copy this file, so we'll even hard code probably the path. But here we just want to JSON dot wait, what? Wait, what happened to my off code? What the literal fuck? Is this thing retarded? Like, what the fuck? I didn't want that to be the shit that was deleted. Fucking kidding me? Shouldn't have to do that, but anyways. Yeah, I usually like to group my imports together. So there's that. Import JSON.loads F. I'm just gonna call this .data. Okay, so we're just gonna have that. We're gonna have the data. And then we have again these files. So yeah, we're gonna have to then apparently when we do this, like match it to the field, obviously match them to the fields in the table. Some will obviously be very straightforward, but some of them we obviously didn't probably didn't do that the exact way in the JSON. So for those we're gonna have to change it a little bit. And so that's kind of what we're gonna try to work on getting straight now. Let me go back and actually just copy the schema over here. That will probably help. Oh yeah, by the way, we should probably push this stuff. Fixing, adding metadata table. Actually for this, I don't care as much about just committing straight to master, because we essentially already applied it. So everything it did already to the actual infrastructure. So it kind of might as well be in master since it was already applied. Sometimes with kind of like the whole terraforms thing and review process, what we would do actually was we would do a PR of the changes and then create a pull request on master. And then only once someone had approved that PR would we actually then run the apply, and then it would be merged. But I mean, once you've run the apply, yeah, I mean, I don't think there's really much point of not having it in master, so I'll just push that there. But yeah, there are different ways of doing that. There's also actually, I think, something called Atlantis too, where it actually works basically. You create like a PR, and then when you merge the PR, it runs through GitHub Actions to actually run the apply, which is kind of interesting. So that is something you can do. But here, of course, it's just very simple. So yeah, I don't really care about sending that directly to the master. But in any case, oh yeah, I was copying that. That's why I got caught up in that anyways. So I'm just gonna throw this in a cell here. Then we'll have all the things. So ID is pretty simple. I think it's literally just going to be ID in there. So let's see, ID and data ID, and then description. So that's what that thing that I think was called name was. Why is this blurry now? I don't know what's going on with this shit. So yeah, that's name. So that's what we're gonna throw in as name. Or wait, no. We're calling that description there. Already that's confusing me. Probably would have been better just call it name, but So we're gonna try to insert this row. So, and then JSON path. So, so yeah, that's not actually going to be in there. What we'll have to do is probably construct that URL. In this case, this would just be this thing. So what we might do is, yeah, just when we copy them recursively, well, this is already going to be a really long line, so data. So actually, I mean, what we might want to do, just to avoid a really long line, is create like a new dict here, and then, yeah, whatever the things are, put it in, and just potentially, I don't know. I think it's the same difference pretty much though. So, data JSON path. I'm just gonna do that there. And so JSON path is going to equal that. So free, yeah, there are a lot of fucking ass fields. State, I think that's just going to be data state, I believe. So yeah, data state. Latitude, that's going to be data. Let me see. I think it's latitude. I know one of them is actually misspelled in these. So yeah, that's right. Latitude. And then it's going to be longitude. Yeah, this is pretty boring. But, longitude, elevation. That might be a little trickier because I think elevation itself might be a dict. Yeah. So you need to do results and then I guess the first thing in elevation. So result 0. And then elevation. It's kind of ridiculous. So I guess it would be that. Wow, that takes almost up a whole line itself. Closest ASOS ID. Closest ASOS ID. So that is going to be, oh well, it's gonna be that like one. We're gonna have to actually go into the station list and then get the ID. Station ID. So yeah, station ID, and then so stations 0 station ID, I think. Stations 0. God, this is a long ass thing. Closest ASOS distance. So then we just go to distance within that too, I think. But once we write this out once, we shouldn't have to do it again. We might, I mean, we'll tweak a couple minor things, but nothing major. So it's this shit again, and then, but then distance instead, I think. Just gonna check that. Okay. So yeah, I think that should be fine. And then, yeah, I don't really know what that is. Cause yeah, a list, yeah, we probably shouldn't have, oh, ASOS list full. Okay, yeah, that's JSON. Yeah, so that's actually right. So what we're gonna do is we're gonna do data. Let's see, data. I think just for data stations. Okay, so data stations. Oh shit. Data stations. And fuck. Oh wait, yeah, that doesn't matter. Closest scan site. So we don't currently have this. I'm just gonna put some random shit in it. Literally. Closest Snowtail triplet that we do have. And that is data. I think that's data, Snowtail, and then triplet or some shit like that. Fuck, there's no Snowtail? What? There should definitely be Snowtail in here. Wait, maybe that one doesn't have it. Oh, it might not have it. Because it might be an Eastern one. So I'm just going to put some weird shit here. And then, yeah, we'll have to write an if statement basically in the final thing. To be like, if it isn't, just put like none or something. So Sentinel tile ID. And then now we're into the home stretch. Just these last couple things. Wait, I don't think we need that. Okay, cool. Sentinel tile ID. So this should just be data. So yeah. So that's just this. Oh, oops. Okay. So there we go. It just needs to be that. And then Sentinel tile path, I think is just becomes data. Tile path. So that looks like it should be good, but oh, it's tile path GCS. So that looks like it should be good. But as we know, there's usually always errors with this shit. So we will try running that. So, okay, yeah, it's all, yeah, I guess it's always tile. Okay, so yeah, so we'll see what happens when we try to run that. So we're only trying to insert one row right now, so we'll try to do that. Longitude. Yeah, I think I spelled it wrong. Yeah, I remember I spelled it wrong initially, which is now creating problems because I don't remember how I butchered. It's longitude. There's no thing, so. Project.dataset.id. So what's the project name? Hydro EarthNet DB. Okay, so that should be good. Let's see if there are any errors. Array specified for non-repeated field.